This afternoon for our September state office webinar. This webinar series is intended to provide ideas and education for current BCE master gardeners. As a reminder, a recording of the session and any resources will be posted on our website underneath the webinars tab, and we are recording this session. The topic of this month's webinar is tree pruning with Jim McGlone. Jim will be our presenter today. I'm going to read his bio for you. Jim McGlone is retired from the Virginia Department of Forestry, where he served 17 years as an urban forest conservationist in Northern Virginia. He is an ISA certified arborist and has the ISA tree risk assessment qualification. Since retirement, he has focused on the environmental education portion of his old job, which he loves and has been told he is pretty good at. He is the primary author of the forthcoming 5th edition of the Tree Virginia Tree Steward Training Manual. He teaches classes to master gardeners, master naturalists, and tree stewards, and speaks to the public on arboriculture, forestry, forest ecology, climate change, and conservation landscaping. He and his wife have been practicing conservation landscaping around their suburban home since 2004. We're going to ask that you hold your questions until we do section breaks, and Jim will let us know when he's ready to take questions. You can type them in the chat or just hold them until that point. And we'll just be adding people that are in the waiting room as we go. So take it away, Jim. Jim, you are muted.
There we go. Thank you. All right, good. We got the first glitch out of the way at the beginning, so everything should go smooth from here. I am Jim McGlone, and I did work for the Department of Forestry for a long time in Northern Virginia. And Timmy Ross is drawing on my slides. Let's see, there we go. So when I was asked to speak, my understanding was that you are all existing master gardeners. You've gone through the basic training class. And so I was asked to add something to that. The bottom line is there really are only two ways you should be pruning branches, and you learn those in basic training. So instead of trying to show you something new or different about how to do that, we're going to talk about why you would prune the branches, and we're going to talk about the biology behind how you do those pruning cuts. Whenever I talk to a group about pruning, I always like to remind people that when you are pruning live tissue from any woody plant, you are reducing that plant's energy production. You're cutting off live branches that have leaves that do photosynthesis and make energy for the tree. At the same time, you stress the plant. You are initiating wound closure, you're opening pathways for pathogens, and you're making that plant more attractive to pests, all of which requires energy to deal with. And you need to keep that in mind, that you have to balance why you are pruning the plant, why you are removing that live foliage against the reduction in energy that you're facing the plant with. Because if you don't think about that, if you can hurt the plant more than you can help the plant when you're pruning. Now, the other thing is, as said in the introduction, I am a certified arborist. And so I teach to the professional tree care standards, which are represented by these two documents here in the United States. The first, the one on the left, is the American National Standards Institute standard for the care of woody plants. There are 10 parts to it. The first part is pruning. The document on the right is the International Society of Arboriculture Pruning Best Management Practices. And as you can see, it is a companion to the NCA 300. Essentially, this lays out the standards. A certified trained arborist should be able to read this and understand what they're talking about. This kind of expands it for new arborists or people who may not be arborists. One of the things that's new in this, in these publications is the idea of rules versus judgment. And the training manual, the book cites, and actually, as I look back at it today, it's no longer really putting these in as rules. They have changed the word from shall to should. So it's more in line with the ANSI standards. But it's always good to remind you, anytime you're thinking about removing more than 25% of the live crown, anytime you're thinking about reducing to a lateral that's less than 1/3 the diameter of the parent, or anytime you're going to be thinking about removing a branch that's more than 1/3 the diameter of the trunk or the parent branch, you should pause. So instead of treating these as hard and fast rules that you never violate, we now treat them more as cautionary and rely on the judgment of the arborist. So they're, as I said, they're more cautionary. If this is part of your plan, rethink your plan and ask yourself, can this outcome be achieved by extending the execution time of the plan? And at the end of towards the end of the talk, I will go into what I mean by that. I will give you an example of changing a plan or creating a longer time frame plan so that you don't have to violate these cautionary things. Some terminology. In the ANSI standard, these are the pruning systems that are covered. The natural pruning system, which is what most of the pruning is, and this is what we're going to focus on in this discussion. This is where you're trying to maintain natural shape and size, and you may be pruning for health, you may be pruning for access or some other reason, but it's not a specialty pruning. They do cover pollarding, topiary, espalier, and bleaching. And in your book, you also talk about coppicing, which is just pollarding at ground level. What is not covered in the ANSI system or the ANSI A300 part is fruit production. There is probably another ANSI part for that, but that's more of an agricultural practice than arboriculture, although I will talk a little bit about fruit production in this discussion. The bigger place is in the terminology that the Master Gardener text uses versus what you find in the professional standards. The way the Master Gardener's text uses thinning, reduction, heading, these are all kind of, well, considering arboriculture is about 100 years old, these are fairly archaic terms in that framework. The professional standard, the professional terms are branch removal, which Master Gardener text refers to as thinning or reduction. And this is where one of the problems comes in. Branch removal cuts are used when you are removing a branch. Reduction cuts are proper in the natural system or even in some of the other systems. It's the removal or the shortening of a branch. So cuts are made at branch unions. Branch removal cut, you're taking away the smaller piece at the branch union. Reduction cuts, you're taking away the larger piece. In the Master Gardener text, they call that heading. Well, professional arborists refer to heading as the types of cuts you make when you top a tree. That's a cut straight across a branch between node points. And the ANSI standards also talk about shearing cuts, which is mostly related to topiary and hedges. And I couldn't find a companion term in the Master Gardener text. I am going to use the ANSI ISA terminology because that's what I'm familiar with. And that is, to me, much more evocative of exactly what you're doing with those cuts. Another point is these lips that form around pruning cuts is reaction or wound wood. I frequently hear people refer to this as callus tissue. There is callus tissue here, but you can't see it. The callus tissue is actually part of the cambium, which is generating this wound wood. So it's not something you can see. It is a microscopic portion of the cambium. The last term I want you to be aware of is aspect ratio. I'm not sure if this is in the Master Gardener text or not, but it's pretty straightforward. The aspect ratio is simply the ratio of the diameter of the lateral branch to the diameter of the parent branch. And if you go back to where I talked about rules versus cautionary statements, that 1/3 is the aspect ratio. So another way of putting it is you should not remove a branch that has an aspect ratio of greater than 1/3. You should not reduce to a lateral that has an aspect ratio of less than 1/3. Now, before we get started, this is what I assume you have learned from your basic training. Protect the branch collar. How to make reduction cuts. And so this is an example of a reduction cut. That you should prune conifers to the trunk. You learned lots of complicated rules for other types of pruning. And you also should have learned the 3-cut method. What I am going to endeavor to do this afternoon is explain why we do these things and why these things happen. Okay? So before we push on into compartmentalization of decay in trees, which is part of protecting the branch collar, are there any questions? I'm clear I can hear that. Okay. So that's just a technical issue about hearing. All right.
Yeah, we don't have any in the chat, so.
All right. We'll move on. Now, compartmentalization of decay in trees. This is something which you did not learn, at least from the manual. I looked at all the chapters where it might show up, and it's not there. This is a fundamental aspect of the biology of trees and how they respond to microbial attacks on the trees. And microbial attacks fall into 2 categories. One is wood decay. These are microbial attacks, and by the way, these are mostly fungi, but occasionally there are bacteria or well, there'd be bacteria involved in some of these. But we have wood decay microbes that attack the heartwood of the tree. These are the same as the microbes that cause wood decay in dead wood lying in the forest or outside the tree. These are somewhat problematic because they do reduce the structural strength of the tree a little bit. But remember, trees follow the physics of columns, and frequently columns are hollow. So wood decay fungi that get into the heartwood of the tree and start hollowing it out are going to do less to reduce the structural strength than the pathogens we're going to talk about in a minute. The other thing is wood decay fungi or wood decay organisms do not kill the tree because they are attacking and well, they're not attacking, but they are consuming dead cells in the tree. So they are going after the part of the tree that is no longer biologically functional. The heartwood, which is no longer being used to transport water and nutrients from the roots to the crown, nor is it being used as a place to store photosynthate. So a tree can be completely hollow and still be perfectly healthy. Pathogens, on the other hand, are attacking the sapwood. These are the organisms that kill and consume living cells. Frequently, they are going after the cambium and the phloem, but some of them do get into the living sapwood, which is the part of the biologically active part of the tree where the tree is still using to raise water and nutrients. These do kill trees. They also significantly reduce the structural strength because what's happening is they're reducing the diameter of the sound wood. And I forget my physics about columns, but that is related to the strength or the structural strength of the tree as they start to kill the outside. Again, these are mostly fungi. Sometimes they're called canker rot or sap rot. Examples of this, sudden oak death, oak wilt, chestnut blight. Those are all things that attack the sapwood and kill the tree. There are very, very few of these microbes that can do both. So when we talk about compartmentalization of decay in trees, it's a little bit different when they're dealing with wood decay organisms because that's in the heartwood and there are no living cells. So there is no new reaction once those get in. With pathogens, it's different because it's in the sapwood and the tree can actually respond to that. So this is what it's all about. If you recall, trees only produce new cells in the meristem. And so if a decay organism gets in there, whether it's a wood decay organism or a pathogen, and it starts eating cells they're already in the tree, those do not get replaced. And what the tree does is it tries to compartmentalize that decay or that attack and keep it from spreading to the rest of the tree. And there are 4 walls associated with the compartment the tree is building. The weakest wall is wall 1, and for wood decay fungi, this is in place when the attack occurs because it's in the heartwood, and part of creating the heartwood is to clog up the vascular tissue, and that is to prevent wood decay fungi from going up and down through the tree. In the sapwood with a pathogen, wall 1 doesn't exist yet. And so what part of the active response to an attack by a pathogen is for the tree to be secreting resins and sap and other things that clog up the vascular tissue. And in some cases, especially with things like elm yellow or verticillium wilt, things that start in the canopy of the tree and work their way down, this response can actually do as much or more damage to the tree as the fungus that the tree is trying to combat, because what it does is it cuts off the flow of water above the fungal attack. And so that's what winds up killing the outer edges of the canopy. Wall 2 exists as part or is created as part of the natural growth of the tree. As the tree grows, as it puts down new wood, it will put down parenchyma cells that act as wall 2. And then at the end of the growing season, it puts down a thick layer of parenchyma cells. And the purpose of wall 2 is to try and keep the attack from penetrating deeper into the tree. Wall 3 is also in place at the time of the attack because these are the parenchymal rays that the tree produces. And again, this is part of the growth of the tree, and the tree is laying down these planes of parenchyma in order to keep any kind of an attack from moving radially around the tree through the a year's growth ring. Wall 4, which you can't see in this picture, is actually where the wound wood comes together and grafts and starts to produce a continuous column or a continuous ring of wood. And as it's doing that, part of what's happening here with the creation of these ram's horns and the eventual closing of the wound is it's putting down a very strong barrier which prevents the decay from moving into new wood. So in this photograph, you can see the coloring here from wall 1, where the tree is excreting chemicals and things to keep the pathogen from moving up and down. Wall 2 is here, where it's trying to keep the pathogen from moving in further, and then wall 3 is here, and eventually you wind up with something like this. This actually is not a very good picture because you should be able to see the ram's horns and the gap that's created as those things are closing over in here because the tree is not filling that in. So here is a micrograph. This is actually a Quercus nigra, a water oak, not a preferred species in urban settings. So if you are down particularly in southeastern Virginia, this is not a good tree to recommend. But what you can see here is if there is an attack, and this would be a pathogen because this is all sapwood, wall 1 would be to clog up. The first thing the tree does is it tries to clog up all of these vessel elements that the tree uses to lift water and nutrients, but the fungal pathogen can use to climb up and down the tree. What you can't see as well is that in these lines that run more or less parallel to the parenchymal rays, these are also very small vessel elements that are surrounded by parenchyma, and those would also be clogged up. So the first thing is, the first wall is to clog up the vascular tissue to prevent the vertical spread of the fungus or the pathogen. Wall 2 are these lines of parenchyma that you can see here. So all of these little lines, what effectively the tree is doing is creating little boxes that it can hopefully contain any pathogen that attacks the sapwood in. And what you can't see as well is there is a very thick wall of parenchyma which stretches just inside these large vessel elements. Wall 3 would be these parenchymal rays, as well as, to a lesser extent, these lines of vessel elements with parenchyma in it, but these are where that really occurs. The other thing to keep in mind is in the sapwood, the parenchyma is living tissue that can create and secrete secondary chemicals. In this case, it would be a fungicide to try and kill the organism that is eating the sapwood. That does not occur in the heartwood because it no longer has any living parenchymal cells. And part of the creation of the heartwood is these parenchymals. The parenchyma secretes those secondary chemicals and infuses it into the heartwood. And then wall 4 would be the new growth out here. This would be when it's growing over a decay thing. This would be a much stronger wall than you would normally find. But that's how the tree compartmentalizes this. So some of the common secondary chemicals that trees produce are glycosides, phenols, terpenes, alkaloids. And juglans is known to produce all of these secondary chemicals. Most of these things are produced to control herbivory. They are all almost all of them are alkali or alkaloids. They taste bad and are toxic. And if you've read Doug Tolomei or gotten into why we should be using native plants as opposed to non-native plants, these are really important, these secondary chemicals, because our native insects have evolved to either use or ignore these secondary compounds. But in addition to these things, the trees are also producing, when needed, fungicides and antibiotics. All right, it looks like we got one question in the chat. And Alex Shigo, yeah, he's going to come up in a little bit. Okay. So part of protecting the branch collar is you want to work with the tree's natural process for controlling decay in the tree. And that's the coated process. The other thing that you've got going on is the is how branches grow and are attached to trees and the evolution of losing branches. So branches start off as primary growth, that's shoots. Over time, every year, the primary growth starts, puts out new shoots, then the secondary growth starts at the top or at the tips of the branches and works its way down. And what happens is the branch gets a new layer of wood, which then gets wrapped over by the new wood from the trunk. And so you get this intertwining of it, and you get this really strong wood at the base of the branch. And you can see here, we'll talk about this in a minute, the branch protection zone, and you can see this was actually not a very good pruning cut because it left this big stub here that the tree had to grow wood around. And you can see those part of the ram's horns here. You can see where it finally came together and grafted, but there is still these voids here where there was no wood grown. A good branch is going to reach into the center of the tree, and you're going to get a U shape in your branch bark and a branch bark ridge. So you can see the kind of U shape here as opposed to the V shape, which would come down and go up very strongly. And you can see the branch bark ridge, which formed as the branch and the tree grew. So this is what Shigo's description of it. This is what it looks like. Unfortunately, this was a relatively large branch on my willow oak that got ripped off, made a big wound. And so we don't want it to do that. But you can see how there's this kind of knob here, and this is the beginning of the branch collar that we'll talk about in a minute. Couple of branch unions. The one on the right is actually a good union. You can see the U shape. You can see the branch bark ridge. That's what you want to see in your tree branches and your branch attachment, because where you see that branch bark ridge, you know that the wood from both pieces is interweaving with each other. On the other hand, on the left, this is a bad union. There is no branch bark ridge. In fact, you can see, you can see a seam running down the tree all the way down to here. And there is actually bark growing in here because these are two pieces that are not knitting together or weaving together under the wood or under the bark. And in fact, they're pushing against each other. This is actually, and it shouldn't be any surprise to you, this is a calorie pair. This is why these things fall apart, is because almost all of their branch attachments look like this. And so eventually what happens is they get so much pressure pushing them apart, it gets hit by a storm, and the whole thing breaks apart. Now, branches, and this is something you may not have been made aware of, is branches are responsible for supplying all of their own food. They have to do enough photosynthesis to support the branch throughout the growing season. Younger branches get a little bit of boost from the trunk of the tree when they get sap flowing up in there to provide energy to support leaf out and new shoot growth. But eventually the branch gets big enough that it has enough storage that it's on its own. The only thing it's getting from the rest of the tree is water and nutrients. When branches get shaded, either in the forest or even in a shade tree in somebody's yard, it's not uncommon for the lower branches to get shaded and die. And then the tree has to get rid of that wood before it becomes a fungal pathway that allows wood decay fungi to get deep into the tree. And so in order to deal with that, they create what's called a branch protection zone. There are chemicals that are stored in the collar, the branch collar, which is the visible part of the branch protection zone. And the cambium there is primed to make the callus tissue and start wound closure. This, by the way, this branch shows you why it's a good idea to prune off dead wood, is because you assist the tree in doing that. But this is also part of that coated system where it is trying to create a compartment around the dead wood and any potential decay in the tree to keep it from going deeper into the tree. And most of that is done in the branch protection zone. So this is why we want to protect the collar, is because we want to protect that branch protection zone, which is an area that is primed to do that compartmentalization of decay in trees. All right. Any questions so far? All right, now.
Hey, Jim, this is Ed. Going back to your picture of the calorie pair, and maybe I missed zoned out because I've got a head cold. Did you use the term included bark, or
Yes.
okay? So that would be included.
So you've got no branch bark ridge here. You can see this seam, which is where the bark is actually going into the interior of the tree.
Okay.
So you do have included bark there.
And that included bark provides no structure.
Well, what's happening is you essentially have two pieces. Yeah, the included bark is not providing any structure. And effectively, you have one tree on this side of the seam and another tree on this side of the seam, and they're getting bigger around every year. So they're pushing against each other, and they're creating a lot of force, which is pushing those two pieces away from each other. And then what happens is a storm hits it just right and reinforces that interior pressure, and the whole thing falls apart.
Thank you.
Sometimes if they get big enough and those separate stems get long enough, just the weight starts to pull them apart. And I've seen that happen with a big hickory that I used to teach the Fairfax Master Naturalists on. It just, for a long time it looked like this. And then one year you could see daylight through it. And a couple of years later, the two pieces were lying on the ground. Okay. So now we've talked about why you protect the branch collar, because you're working with the evolution of the tree, but you're also protecting that part of the tree that is primed for that coated response. So for a long time, this is the way we taught people to do removal cuts. And I think this comes from Alex Shigo. You visualize a line across the perpendicular to the axis of growth that ends at the branch bark ridge, and then you bisect the line and you make your cut like this. I deleted my copy of the old Master Gardener's chapter on pruning, but I think it did have this in it. The new one does not. The problem with this method of cutting, and in the new book, all they talk about is don't cut off that branch bark grip or the branch collar, and you've got to protect it. The problem is that the branch protection zone and the branch collar are not always identical. And in fact, using the Shigo method, or the what the book says about protecting the complete protection of the branch collar, left a lot of pruning wounds that look like this. And you can see there is still part of the dead stub of the tree that's kind of getting in the way of the wound wood closing over that. So it's now been about 15 years ago. There were some German arborists or urban foresters, or I don't remember exactly what their title was, but they studied this and they kept seeing this. And so then they started doing what Shigo did, which was to these things open and see what's going on. And you can see here the branch protection zone. And this would be the cut recommended by Shigo in the book, because this is where the branch collar ends. And so if you make your cut like this, you're going to wind up with one of these things. And so what they have recommended, and is now in the ISA manual, is when you're doing a removal cut, you go outside, you can see the branch bark ridge there. You go outside the branch bark ridge, and essentially you make your cut parallel to the axis of growth here. And that sounds like a flush cut, but it's not. A flush cut would start up here. We're talking about starting out here outside the branch bark ridge. And so what you're going to do is, because this line is not the sole branch protection zone, it's an area here, and making your cut like that, you're not going to leave that little stub there that the tree's got to deal with. So here are the branch collars. This is my crabapple. And you can see, if I were going to make a cut here to protect the branch collar, it would be like this. But when I pruned this tree, I went outside and I went straight down, and this is what it looked like. So I actually did cut a little bit of the branch collar off down here. But what I found is that by making my removal cuts like this, I get, let's see if I can get rid of that thing. I get wound wood that looks like this. It's very symmetrical around the cut. This is not a good cut because it should be closer into the tree. Actually, a good pruning cut on this tree would be at the ground level, because that's a Bradford pear, but that's beside the point. So that's what I'm talking about, is you want to make that cut straight down rather than angled, even though it does cut some of the branch collar because of the way the branch protection zone works. This type of cut better represents that branch protection zone. Now, we talked about those rules at the beginning. And so this is what happens when you do removal cuts, depending on the aspect ratio. So this is why that rule, no more than 1/3 an aspect ratio of no more than 1/3, because generally, if you're below that 1/3 aspect ratio, there are very few consequences associated with it. As you exceed 1/3 access ratio up to 1/2, you increase the likelihood that you're going to get defects in the trunk. And what that means is the tree is not going to be able to compartmentalize the decay, and you're going to start getting decay wounds or pruning wounds that reach into the trunk of the tree. Once you exceed 1/2 aspect ratio, you are likely to have defects. And if you're removing a branch that's big enough to have heartwood of its own, you're also likely to have defects, because remember, in that coated response, the tree can't seal over. What happens is the first response of the tree when you make that pruning cut is the parenchyma that's exposed starts to build sort of like a scab over that cut that then the wound wood covers. If it's large enough to have heartwood, you're not going to get that scabbing and that initial immediate protection that the parenchyma can provide. And notice over here, remember I said about extending the life of the project, as in maybe you don't have to do it all today. You could do something today that will allow you to come back and go from one of these categories to this category. And part of that is shortening the branch by doing removal cuts. And that relates to the whole thing about the branch needs to make its own energy. And we'll talk about that in a minute. Before we get into questions, I want to talk about one last thing. So that's how you do the removal cuts when you have a good branch union. But if you've got a bad union, say, for example, in my friend Joe Rossetti's red bud, you can see no branch bark ridge, the branch or the included bark going in here. He took a picture of this. I don't know why he didn't do anything about it, but then we had some kind of a loading event and the tree split. And you can see this is what tends to happen. You can see the included bark up here. It got down in here. And so the branch split off the side of the trunk, and he finally made a pruning cut down here to remove this broken branch after he'd taken the weight off the top. This is an important aspect of tree care as opposed to pruning. You do have other tools in your toolkit than a pruning saw or pruning shears. So one of the ways to deal with this obviously would be to cut this branch off and get rid of it. But another thing he could have done here is to bolt this union together to reinforce it. And you can see this was done here. This actually was where the tree started to split, and they bolted it back together. And this can be very successful in dealing with especially these types of unions. This would be something you do on a red bud. On a much bigger tree, you might consider, instead of removal, cabling the pieces together. And the idea behind bolting or cabling is simply to take stress off of this joint. But if you catch it early enough, or you decide you are going to take the risk, you can prune these things. And these are pruned differently than where you have the good branch union, because you don't have a branch collar. You don't have the part of the tree that's primed for the coated response. So what you do with This is an elm tree. You can see the included bark here, no bark branch ridge. And so what you do is you cut from the outside of the piece you're removing in, and as you get close to the trunk or the part you're going to leave, you want to be very careful and go very slow, because you don't want to cut into the branch or the trunk that's going to remain. And so this is where we made the cut. This is the cut afterwards. When I looked at these pictures, I realized, we probably should have made that cut a little lower down, but it's always good to cut too high, because you can go back and cut again to lower it. But notice there is no wound on the main trunk of this elm that we're going to keep, because this part in here that has the bark already there, and you can see there's still bark further down. So you would want to cut in ideally until you get past all of the included bark, or to the bottom of the included bark there. And you want to make it a sloping cut, so when it rains, the water will run off rather than pool on top of that cut. Okay, let's see what we got in the chat for this so far. So if a tree has a very large branch and the aspect ratio is less than 1/3, but the branch is dead. Okay, good
More
caveat.
than 1/3, more than 1/3.
More than 1/3. Okay, the M missed. But the branch is dead. So here it is not best to shorten the dead branch. You remove it. Okay, this is talking about when we're dealing with live branches. With dead wood, you make that removal cut. You may want to, if it's a big branch, you're going to want to do the 3-cut method, but you remove it, because it's not going to be able to respond to anything you do further away from the trunk of the tree. Does that make sense?
Yes.
Okay, yeah. Mainly we're talking with dead wood. Let me just make this statement. You remove it. You do still want to protect the branch or the branch collar and the branch protection zone, but by removing it, you're actually helping the tree with a coded response in that evolution of dealing with losing branches. So that's a good thing. What do we got?
I think that's it. I think I just shared
The link.
to
Yeah.
our
Okay.
handbook, the 101
Okay.
version.
All right. Now, reduction cuts. When we make reduction cuts, we need to think a little bit about sprouts with removal cuts, but with reduction cuts, we got to think about primary meristems, because they work a lot with them. So let's review primary meristems in the 3 groups of trees that you might encounter here in Virginia. I think. I don't know. I don't know whether there are palm trees down in Virginia Beach or not. But maybe someday there will be. In gymnosperms, you have apical primary meristem. So that's the bud at the tip of the branch. You have axillary primary meristem, which are the buds that usually form, especially in pines and spruces and other trees, or other trees that have radial branching, right at the base of that apical meristem. And then you'll have lateral meristems in the roots. In dicots, you have apical meristems, you have axillary meristems, but then you have latent lateral buds throughout the tree. And that's what you can see in this picture. These little dimples are actually primary meristem that formed when this part of the tree was a new shoot and has been growing just a little bit every year to stay on the outside. But these things are suppressed by the apical meristem. And then you're going to have lateral meristem in the roots. Monocots only have one meristem, which is an apical meristem at the top of the trunk. And that produces new trunk. It also produces the fronds and the fruits, or I don't know if you ever actually you can see one sticking out here. This is the stems that produce the flowers and the fruit. Monocots are really easy to talk about pruning. You only prune off the dead fronds. If you're going to do a transplant, then you might prune more of the canopy of the live fronds. But pretty much all you do is cut dead fronds and these dead fruiting stems off of it. Conifers are also easy because they don't have those latent buds. We always prune, if you're going to go inside the foliage of a conifer, you go all the way to the trunk. This is somebody who didn't know that. This is an eastern white pine. I think they thought that by doing these heading cuts on these branches, they would produce new side branches. Conifers don't work that way. They don't have the buds there to produce those side branches. That's why you prune to the trunk. And again, you do that removal cut where you're protecting the branch collar and the branch protection zone so the tree can seal. A lot of especially the conifer, the southern yellow pines, things like loblolly, shortleaf, longleaf, etc., they have adapted self-pruning. So they're going to prune themselves at the trunk, whether they're open grown or not. Other conifers like this eastern white pine that didn't evolve for a fire response, they don't self-prune to the trunk, and you have to prune them to the trunk. For the variable leaf, it's the same thing. They don't have those suppressed buds that you can manipulate and get them to grow more. Makes it real simple to prune conifers. When it comes to dicots, when you make your pruning cuts, you may release those latent buds and get sprout formation. And so this becomes part of your planning. Do you want sprouts or do you not want sprouts? And you make your cuts accordingly. There's a way to do a reduction cut that prevents sprouting. There are ways to do reduction cuts that encourage sprouting. One of the things I want you to understand, because this is something that I hear a lot about. The first time I heard it, it did not make sense to me. A lot of people call these sprouts suckers, as in they are sucking the life out of the tree. They are somehow damaging the tree. And that is crap. These are the same as your normal spring sprouts. Yeah, when they first form, they're a carb sink because they don't have any carbs in them. And so they're pulling carbs out. But once they put leaves on, they start supporting themselves. And this is how dicots have evolved to respond to stimuli. I call this Plan B, because if a dicot gets damaged in a storm, these latent buds are there to help it respond to that damage. And sprouts form as a stress reaction to pests or disease or wounding. They may form as a stress reaction to pruning, depending on how you prune. So, for example, this is an ash tree that's being killed by emerald ash borer. What's happening is all the branches in the top of the canopy are dying And the tree is releasing these buds to form new sprouts to compensate for the loss of those dead branches in the canopy to rebuild that photosynthetic surface and potential. Another reason that you might see sprouts on a tree is suddenly the tree is exposed to more sunlight. For example, in development where they clear part of the woods and trees that had been growing in the interior are now on the edge and suddenly they're getting a lot of sun. So they put out sprouts to take advantage of that new sun exposure. Other trees reproduce by sending up sprouts from their root systems, things like pawpaws and sumacs, aspen. I think the largest plant, depending on how you define a plant, on the continent or in the world is an aspen that is all root suckers, and it covers over an acre. So it's a huge piece of it's a huge connected plant. But these sprouts are part of tree evolution. When you see sprouts, don't think, oh my God, those sprouts are bad. I got to get them off the tree. Think, oh my God, the tree is sprouting. Why? What's causing it to respond this way? What is the stressor? What's the disease? What is driving these new sprouts? So that's one of the things that, I've taught classes and I've been out on pruning practicals, and I've heard master gardeners talk about, oh, we got to get rid of these sprouts because they're sucking the life out of the tree. It's not the case. They're there for a reason, and you need to figure out why they are there. Okay? So the big thing about reduction cuts is we're managing sprouts. City of Richmond protected microclimate, and four palm trees around the pool. Okay. Yeah, that probably, and that's wrapping the crown of the tree in the winter. That's like if we get a hard freeze warning and you've got delicate shrubs, sometimes you go out and you put burlap on them or something like that to create more of a microclimate and trap more of the heat in there. And the part of the tree that they really need to protect is right there in the canopy. So they're doing exactly the right thing. Okay. So in the natural system, we generally want to control sprouts. So this is how and I still think this is a good way to teach people to do a reduction cut. This is, again, I think from Alex Shigo. You visualize a line perpendicular to the axis of growth of what you're going to cut from the branch bark ridge, and then you bisect that angle. In the book, they just say, well, this cut's too steep, this cut's too flat. This is a good way to do it for almost any species. So you won't get a cut that's too steep and you won't get a cut that's too flat. And what you're doing here, the reason you want to go to a lateral that is less or more than 1/3 the diameter of the parent is you are allowing the terminal bud of the lateral to take over responsibility for suppressing the buds in the parent branch below the cut. So by making cuts like this, you are going to be continuing to suppress the latent buds and not get sprouts. So here is an example. This is a smaller tree. You'll see this again, but here is visualizing the line. And then I used my pruning blades to visualize the line, then I rotated down and made the cut. The bisecting the angle is approximate. Don't worry if it's not what you would get if you were to go out there with your protractor and your compass and things like that to figure it out. And when you do that, when you do these cuts, I made this cut, I think, in 2007. This is what it, looked like a year later. And here's what it looked like later on, and notice there were no sprouts associated with this cut. Now, this gets into all of those esoteric rules for other types of pruning. You can also do reduction cuts where you are creating sprouts either within the natural system or other systems. So within the natural system, you want to create sprouts for rejuvenation pruning. Typically, this is been something you do with shrubs. And what you're doing is you're reducing the buds or laterals that have less than 1/3 the aspect ratio. So this is my Amorpha fruticosa. You can see all the cuts I made to rejuvenate this thing. This is the next year. You can see all the sprouts that came off of it. We use this type of pruning, and this is where we are, quote unquote, mismanaging it, making bad cuts. Sometimes people say that, because what we're trying to do is actually release those buds and create new sprouts. So rejuvenation of shrubs. There are some arborists who are dealing with really old trees that are going into retrenchment and they start to get holes in the canopy, and they're doing exactly the same thing around that hole to get more sprouts so they can have more leaves taking advantage of the sunlight that's being made by the holes in the canopy. Also, this would be if you have a hedge that you've let get too tall and it's a dicot plant, because this is not going to work on an evergreen, on a gymnosperm. But if it's a dicot, like a boxwood hedge, and you want to lower the hedge, as you do that, you want to get into the middle of that, the plant, and start making these reductions to buds that are pointing inwards, reduction to small laterals that are pointing inwards, because you want to generate sprouts to fill in what would otherwise be a big hole in the top of that hedge from cutting it down. I've heard some people say something about, oh, well, I've got a tree that only flowers on new wood. This has nothing to do with that. Flowering on new wood what that means is the flower buds are being formed as part of the spring growth at the beginning of the year. So trees or shrubs that flower on new wood, like Clothronifolia or shrubby St. John's wort, they do not form flower buds at the end of the growing season the way azaleas and dogwoods do. So that's what it means by flowering on new wood. Yes, this will tend to eventually increase flowering, maybe, but what's going to happen, as you can see in this case, is a lot more of the energy is going to be going into producing new shoots that are going to have leaves on them to replace a lot of the energy that's lost here. Another place where they do pruning that violates the natural system is in fruit orchards, particularly in apple orchards. And here they're making what we would normally consider bad cuts with the idea that they're going to produce sprouts that are then going to be able to produce more flowers and increase the production of fruit there. We also make so-called bad cuts when we do espalier, which is very similar to pruning the apple trees and other fruit trees. And this is where we're trying to produce sprouts that we can then train to these wires of the trellis and wind up with a plant that looks like this. Or here are some others. This, by the way, is at the greenhouses at Mount Vernon. So eventually this tree will be transplanted into a setting like this. George Washington used espalier for his fruit trees in his kitchen garden so he could get fruit production but not take up a lot of space from a three-dimensional canopy. When you're doing pollarding, again, this is managing this plant specifically for these sprouts. And what happens is after 2 or 3 years, you come back to exactly the same place and you cut those sprouts off. And eventually you get all this wound wood that's making these big knuckles at the ends of the main branches. And coppicing is pretty much the same thing, only you're doing it at ground level. So that's, you got all these rules about how to do things, but all that's going on here is you are controlling the production of sprouts. Either you're making your cuts, which is the standard one that I showed you, at a lateral that's got an aspect ratio of greater than 1/3, so that you don't get sprouting, or you're reducing to a bud, which is essentially a lateral that's way below the 1/3 aspect ratio, so that you can get sprouts, because that's what your pruning plan calls for, is you want sprouts. And it all gets back to that 1/3 aspect ratio and making that pruning cut, that reduction cut that prevents sprouting, or not making a reduction cut that allows sprouting. By the way, if you are going to decide you want to pollard your tree, the right way to do it is to make a bad reduction cut at a branch node, not just go in there and cut straight through, do a heading cut between branch nodes. That is going to invite or encourage decay getting into your tree. Okay, any questions about these reduction cuts and how it relates to the biology of the tree? I don't see anything new in the chat, so we will go on. Now, you learned how to make you learned about the 3-cut method. What you didn't learn is why. And the reason is shear planes. So here we have the trunk of a tree, here we have a branch. Because of gravity, and you can do this with your own arm, just stick it straight out. And when you do, what you will feel is, if you get your palm down, you will feel a stretch in your bicep at the top and compression in your tricep at the bottom. And the same thing happens with a tree. So because of gravity, the wood at the bottom of the branch goes into compression. The wood at the top of the branch goes into tension. And there is a transition there that's called the shear plane. And sometimes a branch will fail along the shear plane because the wood fibers will come apart and you wind up with something that looks like this. This is why we use the 3-cut method, which looks something like this. You make your first cut on the underside up into, doesn't have to go all the way to the middle of the branch, but it should go at least 1/3 of the way in. Then you make your second cut, which goes all the way through the branch, or at least as far as until the shear plane fails, and you wind up with a cut like this. You wind up with something that looks like this. So notice the shear plane failed and it would have torn all the way down this branch, except it stopped where I made that first cut. And that's the whole point of that, is to take as much of that weight off the branch as you can. And that first cut is there to stop the rip. Okay. Then once you have made your these first 2 cuts, you go in and you make your third cut where you're removing the stub that you should be able to control pretty easily with one hand. And the result then is this is your final cut. And that first cut prevented any type of a tear that would go down into the tree. The other thing to notice is the center of growth on this branch is actually here. And it's been putting on a lot more wood because of the compression that the cambium here was under to support the weight of the branch. This is a great example of how cambium tissue responds to either tension or compression. And in fact, it is the result of cycles of tension and compression as a tree sways in the breeze that creates the taper that is made by the cambium, recognizing the physical stress and responding to it by creating more wood fiber to support the tree. If you don't use the 3-cut method, you wind up with something like this. Now, to be fair to my neighbor, it is possible that, I started to say that it is possible that the branch, well, it is possible the branch cracked somewhere up here and tore down, and then he just had to cut the end off here. But this is what can happen if you don't use the 3-cut method. Now, the shear plane, just because you see a shear plane crack, and even if you can see daylight between them, doesn't mean you have to do anything about it. This is a branch that experienced a shear plane crack. I was walking in some neighborhood giving advice on taking care of trees, and I saw this. Notice that because nobody saw it earlier, this thing is healing itself. You've got, you're seeing grafting of the wound wood here, and you can see the wound wood coming together. And these two grafts will come together eventually, and you'll have sound wood going all the way around the tree. Now, if you saw this when it was fresh, you might be tempted to try and take this off, although this was a pretty big piece of wood. Excuse me. But again, instead of using your saw or your pruning shears, you can bolt these things. And what that is, in this case, it'd be like a suture where you're pulling that wood fiber together and enhancing its ability to form that wound wood and graft it and eventually seal over that wound. Sealing. Definitely sealing. Healing implies that it's producing or it's using, it's creating new tissues to close up the inside of the wound. What's going to happen is the tree eventually seals over these wounds with new wood that goes all the way around them. But it's still, as I said earlier, it still will have a cavity in there if it was decay, or in the case of these shear plane cracks, it still will have that spot where the wood fiber is not connected between itself. So if you were to cut that down and through it, you would have a space, a gap between those wood fibers. All right. So this is a case study in training a young tree that kind of brings together a lot of what we just talked about. So in 2008, I looked at my crabapple tree, and I noticed that it had two problems, or two glaring problems. One is this branch was becoming a competing leader, which is not good. The other is I had this vigorous branch down here that was actually growing out towards the street. Notice that the aspect ratio here is about what is maybe a little over 1/3. It's tending towards 1/2. And here the aspect ratio is close to 1. So based on what I've already talked about, these two branches were probably, this one definitely was too big to remove at this time in 2008. This one was potentially, it was close to being too big to remove, but because of the way it was growing, it had the potential that if I could slow it down and subordinate it to the trunk of the tree, that it could become a scaffold branch for the tree. So in 2008, I looked at that first problem and I said, okay, I don't necessarily want to, this branch has potential, but it is growing improperly. It's becoming a competing leader, and I didn't want that. So remember, branches have to make all of their own sugars. So what I did was I went out there, and you already saw this pruning cut that I showed you, and I reduced this branch to a lateral that is greater, that has an aspect ratio of greater than 1/3. And there I made the cut, and this is what the cut looked like in 2008. 3 years later, this is what the cut looked like. And notice here you have a distinct kink in the branch where this lateral is much smaller, or is smaller than the remainder of the parent branch. 3 years later, the pruning wound is almost completely gone. The kink is gone, and now these things look like they're about the same size, which is nice for that branch. But this is what happened at the branch union. So here we have an aspect ratio that's maybe a little more than 1/3. Here it is significantly less than 1/3 and continues that way. And notice I never did remove the branch. It became one of my scaffold branches. The other problem where I had this vigorously growing, very big branch down here in 2008, very much bigger than the that 1/3 aspect ratio. So I knew I didn't want to make a big wound on the trunk of the tree, especially that low. So I did a reduction cut here. Might have violated that 1/3 aspect ratio, but that was because I didn't want to take too much of this branch off, and it didn't have a lot of big side branches. So you can see here, this was probably my best choice, given that 1/3 caution. So in 2008, aspect ratio is close to 1. By 2011, notice how by doing that reduction cut, I slowed down the growth of that branch, and now the aspect ratio is way below 1/3. So I could cut that branch off with impunity, which I did. And 9 years later, this is what the wound looked like that I made when I did that reduction, when I dealt with this branch. But in 2008, I made a plan that turned out being 2.5 years long to do a reduction cut to slow down the growth of that branch relative to the trunk, so that later on, I was no longer violating that 1/3 aspect ratio for the removal. Okay. One last thing I want to talk about is root pruning. They do talk about root pruning in the book. Mostly it is in terms of transplanting trees, but you are more likely to do root pruning in association with planting. So there are some things about root pruning. First of all, we no longer worry about whether or not we're making heading cuts. In fact, we want to make heading cuts usually when we're root pruning. You always want to use a sharp tool to make cuts as clean as possible. Depending on where you're why you're cutting and what's going on, if you can, and if it's applicable, you want to expose the roots before cutting, if you can. So if you're doing root pruning in association with, say, construction, you want to try and expose those roots. But if you're doing root pruning in anticipation of a transplant, you don't want to expose the roots. There is a rule of thumb for root pruning, and that rule is that roots that are smaller than your thumb, about 1 inch, will seal and sprout vigorously when cut. So we don't worry about cutting roots that are less than 1 inch. They're going to fix themselves very quickly. This is not true for monocots. Monocots rooting is weird. You can read about that if you ever get palms in an area where you have to worry about it. The other thing to keep in mind is the bigger the root is, or the closer to the stem, the more of the root system you're losing when you make those cuts. Trees are constantly growing and shedding small roots. They sense a pocket of nutrients or water, and they send us a root over there. Once it's gone, they drop it. In fact, over the course of a year, trees usually are shedding as many as the mass of shed roots for a tree is almost equal to the mass of the leaves that they shed. And as I said, this is generally done with a heading cut. And this is what I mean by a heading cut. So you've got a branch, you've got branch nodes, and you're making a perpendicular cut between branch nodes. This would be in the crown of the tree. This would be a topping cut. And generally we don't make those. Here's what I mean by pruning, root pruning associated with planting. You get a plant, you pull it out of the container, and this is what the root system looks like. You can see there are roots here that are growing in the wrong direction. There are other roots growing in the wrong direction. Now, I've seen people do many different things associated with that. The way that you deal with this is you slice off the outer 1 inch of the root system, and you do it in chords. So make your cut here so that the part that's coming off, the thickest part, is about 1 inch. And you go all the way around the root ball. And if need be, you do the bottom. And then you plant it the way you normally would. This is where you're much more likely to be doing root pruning than in transplanting plants or stuff like that. What this is doing then is where you have problematic roots like this, you're cutting them off to where they are growing straight out away from the center of the trunk or the center of this shrub. And so when they continue to grow, they're going to continue to go straight out because they don't have the container to turn them and cause them to grow in the wrong direction. One thing I will tell you, it's not associated with pruning, is when you have a root system like this, you're going to need to do a lot of supplemental watering because it's going to take a while before those roots reach out into the rest of the soil column to start gathering water. So it's only going to be using the water in the root ball. And with this many absorbing roots in it, it's going to dry out the root ball very quickly. Fortunately, we planted this near the front door, so we were able to monitor it. And even during drought, when we were watering the other plants, we had to water this one twice as much. And that's it. That's what I wanted to talk about. And now I will answer your questions.
I don't see anything on the channel. I don't have anything. If anybody's got questions for Jim, feel free to unmute and ask them.
I have an obscure question. I observed a tree at a client's property. It was a giant catalpa tree that had become hollow in the inside. And at some point in this tree's life, a branch was cut and the tree became hollow and bees were going in where the branch had been cut. So they stated that they tried many different ways to it weren't bees, they were hornets. They tried many different ways to get rid of the hornets, and they finally filled it up with the foam that you can spray in your house.
Okay. Not the ideal solution, but it could have been worse. They could have used concrete. At least the foam is generally going to have some give and take. If they're hornets or yellow jackets, if they're wasps, then my recommendation would be just be aware of them, observe them. Where you see them going in and out of the hole, do not bother that area. Just stay away from it, and they will be gone next year because they only overwinter as queens, which will then leave that space. They'll go find some place to overwinter, and then they'll find a new place to build a colony next year. The same thing with bumblebees. Honeybees might use the same spot year after year. And in that case, it would be better to contact a local. There are a lot of honeybee clubs around, and some of them usually have people who are looking for hives, and they know how to get the hive out of the catalpa and to someplace they want it to go.
These were definitely hornets, and they were able to stop them one year, and then this year they sprayed the foam in because the hornets came back to the same place.
Okay. That's the one thing to keep in mind is that if it's a good place for a hornet's nest, it won't be the same colony that's there next year, but if it's a good place to have a colony, then maybe somebody else is going to move in.
I got you. Thank you.
I had a question if a lot of these apply to fruit trees, and I respond in the chat that it can be very different. But I think that attendee must have lost connection during your part on fruit trees. It's different in a lot of ways, but the tree health and tree physiology part is very similar. It's just the end goal for the tree that's different.
Yeah, it's the way you're manipulating the physiology when you're pruning those fruit trees, because you want sprouts as opposed to not wanting sprouts. But if you notice, they say that once the branches of your apple tree, for example, get as long as you want them to, instead of using those kinds of heading cuts or what an arborist would call a heading cut that's going to produce sprouts, you use a reduction cut and you do it in a way so that it doesn't produce sprouts. So it really depends on what you're trying to do to the tree. If you're trying to make it sprout, then you want to use you want to do a reduction cut differently than if you're trying to just control the size of the tree.
Yeah, and it will vary based on what kinds of fruit trees you're pruning as well, the age of the tree and the pruning style, because apple trees pruned on trellis are treated differently than peach trees that are freestanding and lots of other stuff. Carol has a question. She said she has a red maple that looks like the picture with the bark that is peeled off. Does that mean her tree is dead? It also looks like all the leaves are dead. It probably means that there's some health issues with the tree, right?
Definitely.
Definitely.
Yeah, if the bark is peeling off of the tree like that, that's a good indication that if it's not dead yet, it's going to be soon. That is a really bad sign. And if the leaves are dead now and not falling off, it's definitely dead. What most people don't realize is that leaf drop requires energy to build the abscission zone and the scab there, so the leaf can fall off without creating a wound on the side of the tree. If the tree dies in midsummer, for example, and it has a bunch of leaves on it, that's not going to happen because there's no energy, there's no biology there to cause the leaf drop. So the leaves just kind of dry up and stay on the tree. That's a really bad sign for that part of the tree, that part is dead. Dogwoods. I don't know if you want to necessarily leave them alone, but you should be aware that right now the dogwoods already have their flower buds on it. So anything you prune off, you're not going to get flowers there. And it's become a bit of an issue now that we are gardening, not just for flowers and pretty, but also gardening for birds and caterpillars, because it becomes difficult to figure out. It used to be just say, well, you prune your dogwood after it's done flowering. But when you do that, you're cutting off the berries that you might want for the birds. And so my recommendation there again is make this a multi-year project. If you need to prune your dogwood, then prune maybe a third or a half this year and do the other half next year, so that you're not losing all your flowers or all of your berries. I think I saw somebody who asked about espalier.
There's a question on, do you have any recommendations on how to espaliate? I would think that depends a lot on the species that you're working with, because some are a lot easier to do that with than others.
Yeah, it is. But basically, that's another question of, and the way you would normally do that is first you put up your frame that you're going to train the tree to. Then you plant a whip. And once the whip gets above the first wire, you do a heading cut on it. You cut through across the node, away from a node, so that it will produce sprouts. And then what you want to do is take one of those sprouts and train it along your wire, or two of them along the wires, and then another one you start training to go up to the next wire, and you keep doing that. But that's another place where you want to make a cut that is going to allow the tree to sprout, rather than make the cut so the tree doesn't sprout. Because when you're establishing that espalier, then it becomes, you need those sprouts to work with. Once you have all of your branches starting to be trained lengthwise, and it's now starting to get up above the frame, that's when you start going to those reduction cuts like I showed you that prevent sprouting, because you don't want any more sprouts coming off of those things. And the same thing is going to be true, although those are going to be mostly removal cuts, when you start to get sprouts that are growing out away from the frame, from the branch.
About a lightning hitting a tree, and we have a question about a large willow oak tree.
The tree is still thriving. Should I cut it down or leave it alone? It looks like I could cut the right side off. So I'm not sure what you mean by it split the trunk. Did it go straight down the middle of the trunk and produce what looked like toothpicks coming out? In which case, if the tree is still thriving, depending on how big it is and depending on how much risk there is associated with it, that would be a place where you might bolt it together and almost treat it like a shear plane crack. If you want to keep the tree and there's not a lot of risk to, if it fails, that it's going to do a lot of damage. So that's one of the ones where it really kind of depends on what the species is, where it's located, how big the tree is. There are lots of different considerations there, but you don't necessarily have to cut it down. And I certainly would not just cut one side of the tree, because then you're leaving a huge wound for the tree to close. Now, for some species, it might do that. I do see trees that I can look at and look at the wound wood and know that tree was struck by lightning 15 years ago, and it is doing its best to get better. But in this case, I would not recommend that. And again, it really depends on where it's located on the property. If it's a pretty big tree and it's 20 feet from your house, I wouldn't be comfortable with that tree in my property. If it's right up against the house, this is another thing that people don't realize is those trees that are growing right up against the house actually have less risk if they fail, because they don't have any time to get momentum up if they fall towards the house. So they'll just kind of lean over and lean against the house. They may break the gutter or the eaves if it's a big tree and it's leany and it's unsupported, but it's not going to cut the house in half because it doesn't have time to get the speed up that comes from that. Question about a very large willow oak that was pruned last winter.
Yes, that's my question. It's Ginny Zabel.
Okay.
And and this it's about a 40-year-old willow oak in my front yard. It's been pruned on a number of times, but this past winter, they probably pruned a company came and pruned it like in February. They pruned out deadwood. They also pruned other limbs, and they pruned off all the little branches along the branch, the main bigger branches. So since they all started growing little branches, and I have filled two great big lawn and leaf things with the little branches coming down. I've never had this happen before. Should they have pruned off all those little branches? Because every place they planned a branch, little tiny, small branch. I got another branch that was not big enough to withstand winds.
Right. That is a variation on a pruning technique, which is called lion tailing.
Okay.
Which basically is you prune off all of the interior branches and you only leave branches on the outside. And frequently, you'll see this particularly like in parking lots where the stores want people to be able to see their signs. So they prune all those lower branches and they leave all the branches at the top.
This was not lower branches. This
is a variation also where they prune all the interior branches. And the thought there, I guess, is that that's going to reduce wind resistance, but actually what it does is it increases it because you lose all the mass dampening. And it sounds like they pruned enough live tissue that the tree is trying to respond by growing new branches and new sprouts to replace all that lost photosynthesis. So it's unfortunate when this happens. There's not a lot you can do, but pray and hope it gets better. It's not like a haircut. It's going to if it's a bad haircut, you could, shave it all off and start over again. It doesn't work that way with the trees. But my recommendation would be to let those sprouts go for a while and manage them as they start to come in, rather than just go in and cut off all those. Because if you go in and cut off all the little sprouts, they're just going to come back. The tree is trying to tell you, I need more leaf surface area.
Well, I could not. I mean, the branches are up 20 feet.
Okay.
It's way up. It's all up in the top of the tree.
So here's the other thing is don't ever let that company touch your tree again.
Well, that's what I wondered if this should have been done. They have done it before. This is the first time I've had this happen.
Okay.
And it is a certified arborist company. So.
Yeah, but they may not have certified tree climbers. And frequently the certified arborist is a salesman, and then they send the crew out to do the work. And if the crew doesn't have the right training, they don't do it right.
Okay, so I should make sure that never happens again.
Right.
Okay, thank you very much. That's helpful.
Yeah.
We have
How do you
time to do two more questions.
Okay.
And I know this is really great content and very good answers from Jim, but I just want to be respectful of everybody's time. So we have a question about when the best time to prune is, and we have a question about leggy boxwoods. So
right.
maybe you go start with the best time to prune. Because I
So-
know it varies a little.
Yeah. So here's the thing. You can prune any time of the year. A lot of it depends on how much you're going to prune. If you're going to do a heavy pruning, I would recommend doing it in the winter. So as leaf out occurs, the tree is going to start healing those wounds or sealing those wounds earlier. Then there are tree health issues. So for example, for elms, you don't want to prune in May and June because that's when the elm bark beetles are flying. And when you prune a tree, you stress it. And when you stress a tree, its coloration in the UV spectrum changes. The chemicals it gives off changes, and the insects can sense that, and they know that tree is stressed, so its defenses are down. And so if you prune an elm in May and June, it's going to attract those elm bark beetles, and that's one of the vectors for Dutch elm disease. So you need to be aware of those things. In terms of flowers, this is for not for flowers or fruit. If you're going to be doing light pruning, like I showed you on that one tree, you can do that any time of the year. The tree will respond to it. If you prune in the early summer, just after the tree has leafed out, you need to keep in mind that the tree just spent a lot of energy putting on those new branches that you are now cutting off. And that is a bigger stress on the tree than if you prune in the winter, where the tree doesn't produce or use the energy to produce those sprouts. So it doesn't, and if you're trying to slow down the growth of the tree, pruning in June and July is a good thing to do because you're stressing that energy system, and next year it won't put as much energy into growing new shoots. So it really depends. You need to think about how is this affecting the energy balance of the tree? What's out there that could potentially harm the tree? But the idea that you can only prune in the winter is no longer the case. And like I said, it also depends on how much you're doing. If you're going around with your hand pruners and just nipping here and there, you could do that anytime. So the last one is leggy boxwoods. I pruned punch holes. I pruned punch holes to let light, but I still only have foliage at the ends of the branches. So this looks like a case where you're going to have to sacrifice some of the height of the tree. You really need to prune back to those interior facing or exterior facing buds and small laterals to get the tree or get the well, actually it is a tree, because if you don't prune boxwoods, they do create a tree form. But to get them to start sprouting along the branches and produce more foliage. This is almost like rejuvenation pruning, only you're not going all the way down to 12 inches, but you do need to prune those branches back and get them start to get the shape you want, and then start to manage it as you go out. This is a long-term project. So you may have to go down to 2 by 2 and then work your way back up to 3x3 by doing yearly pruning to manage new sprouts.
Should I take out complete branches then, or just cut it back a foot on each side?
It depends on what they look like. If they don't look really good, don't have a lot of buds on them, yeah, you could take out a complete branch. But mainly what you're looking at is, you know, kind of cutting them back to a small lateral, either a bud or a small twig, that's going to release any buds that are down below the cut and start making new sprouts.
Okay.
Okay. I don't have anything planned till 7, so I can.
No, we really do appreciate it. This has been very informative. I like the higher level content and how you incorporated the plant physiology and plant pathology aspects into this. I think it's been really very good for our volunteers. So, everybody, thank you to Jim. And like I said, this will be recorded and posted online for you to review. If it was a lot of content all at once, that's okay. It's online for a reason. So, everybody thank Jim, and thanks for signing on today.
You're welcome. And thanks for joining me. Although I don't know what the weather is where you are, but it's a good day to be inside talking about pruning in trees rather than outside actually doing it.
Yes, thank you.